Hello. Today we will discuss about implementation of linked list. Next. Okay. With group leader Besin Elijah and members Baldorado, Mark, Bautista, Fonzy, Racelis, Winston, Hector, and Sayno, Vincent, Paul. Linked list. Like arrays, linked list is a linear data structure. Unlike arrays, linked list elements are not stored at a contiguous location. The elements are linked using pointers. So as you can see by the example here. Next. Why linked list? Arrays can be used to store linear data of similar types, but arrays have the following limitation. Number 1. The size of arrays is fixed, so we must know the upper limit on the number of elements in advance. Also, generally, the allocated memory is equal to upper limit irrespective of the usage. Number 2. Inserting a new element in an array of elements is expensive because the room has to be created for the new elements, and to create room, existing elements have to be shifted. But in linked list, if we have the head node, then we can traverse to any node throughout it through it and insert new node at the required position.
So for example, in a system, if we maintain a sorted list of IDs in an array, ID is equals to 1000, 1010, 1050, 2000, and 2040. And if we want to insert a new ID, 1005, then to maintain the sorted order, we have to move all the elements after 1000, excluding 1000. Deletion is also expensive with arrays until unless some special techniques are used. For example, to delete 1010 in ID, everything after 1010 has to be moved due to this so much work is being done with affects the efficiency of the code. Advantages over arrays. 1. Dynamic size. 2. Ease of insertion and deletion or deletion. Drawbacks. Number 1. Random access is not allowed. We have to access elements sequentially starting from the first node. Each node, so we cannot do binary search with linked list efficiently with its default implementation. 2. Extra memory space for a pointer is required with each element of the list. 3. Not cache friendly. Since array elements are contiguous locations, there is locality of reference which is not there in case of linked list. Representation. A linked list is represented by a pointer to the first node of the linked list. The first node is called the head. If the linked list is empty, then the value of the head points to null. Each node is a list consists of at least two parts. 1. Data. We can store integer, strings, or any type of data. 2. Pointer or reference to the next node. Connects one node to another. In C, we can represent a node using structures. Below an example of a linked list node with integer data. Node class, class node. Function to initialize the node object. Def initialize self data. Self.data is equal data or the assigned data, then the self.next is equal none initialize next as null. Next is linked list class. Class linked list. Function to initialize the link list object. Def initialize self. Self.head equal none. A simple Python program to introduce a linked list. Node class class node, function to initialize the node object. Def initialize self data. Self dot data equal data or the assigned data, then self next, none, initialize next as null. Linked list class contains a node object class linked list. Function to initialize head. Def initialize self. Self dot head equal none. Code execution starts in here. If underscore name equal to main, start with the empty list, list equal linked list, open close parentheses, list that head equal node with parameter 1, I with node with index 1, second equal node 2, third equal node 3. Three nodes have been created. We have references to these three blocks as head, second, and third.
So this is the continuation of the Python in list that head, second, and third. First node, second node, and third node. List that head, that next equals second. Link first node with second. Now next of first node refers to second. So they both are linked. List that head, second, third. Second dot next equals third. Link second node with the third node. Now next of second node refers to third. So all three nodes are linked. Next. Linked list traversal. In the previous program, we have created a simple linked list with three nodes. Let us traverse the created list and print the data of each node. For traversal, let us write a general purpose function print list that prints any given list. So here is a simple Python program for traversal of a linked list. Node class node, function to initialize the node object, def initialize self data, self.data equals data, which assign data, self.next equals none, which initialize next as null. Linked list class contains a node object, class linked list. Function to initialize head, def initialize self, self.head equals none. This function prints contents of linked list starting from head. Def print list parenthesis self. Temp equals self.head while parenthesis temp print parenthesis temp.data temp equals temp.next. The code execution starts here. If double underscore name is equals to double underscore main, start with the empty list. IList equals linked list. IList that head equals node with parameter 1. Second equals node with parameter 2. And third equals node with parameter 3. IList that head that next equals second, which is linked first node with second. Second dot next equals third, which links second node with the third node. IList dot print list. This code shows an output of 1, 2, 3. That's all. Thank you for listening.